welcome to a ramble with me. We are looking at question 10A of IEB paper 1 November 2022. Let's go. You are given the following numbers 1, 3, 6, 8 and 9 to use in creating 5-digit numbers. How many unique 5-digit numbers can be created if repetition is not allowed? Okay, so 5 slots, and in the first slot we have a pick of 5 numbers. The next one we can only choose 4, then 3, then 2, then here we only have one number that we could choose. So the number of unique 5-digit numbers that we can create is 5 factorial, which is 120. Okay, next question. What is the probability that a unique 5-digit number starts with an 8 and ends with a 3 if repetition is not allowed? Okay, so we have an 8 in the beginning, 3 numbers in the middle, and then a 3 at the end. So here we have 3 possible numbers we could choose, right? It's either the 1, the 6, or the 9. And then here there'll be 2 numbers left, depending on what we choose here. And then here there'll be 1 number left. So there are 3 times 2 times 1, that is 6 numbers that start and end, that start with an 8 and end with a 3. So the chances that we choose one of those is 6 out of 120, which is 1 out of 20. Right. Then for the last one, how many unique even numbers greater than 65,000 can be created if repetition is not allowed? Okay, so the numbers we have are 1, 3, 6, 8, and 9. Okay, so we need the numbers to be greater than 65,000. So if it starts with a 6, then this number here either has to be an 8 or a 9. Then, okay, 1, 2, okay. And then it has to be an even number. So it has to end with, well, yeah, we only have 2 even numbers here, 6 and 8. So we can't use the 8 here then. It would have to be a 9 here and an 8 over there. So then that means here we have 2 options for a number. It could be 3 or 1, and then here there's only 1 option left. So the number of numbers we can get here is 2 times 1, which is 2. Okay, and then alternatively it could start with an 8 or it could start with a 9. Okay, and so I mean, just by virtue of it starting with an 8, it's going to be greater than 65,000, so this could be any number. So the next thing we care about is the number it ends with, so that it can be even, and it would have to end with a 6. So that means that here we've got 3 options. It could be the 1 or the 3 or the 9, and then here we'll be left with 2 options, and here we'll have 1 option. So the number of unique numbers we get there is 3 times 2 times 1, which is 6. Okay, and then the last possibility is it starting with a 9. And in order for it to be even, it would need to either end with the 6 or with the 8, right? So there are 2 options for numbers over here. Over here, I mean, okay, so what am I tempted to do? I'm tempted to split these cases up. So so either it ends with a 6 or it ends with an 8. So then here we're left with 3 options, 2 options, 1 option, and then similarly here. So something tells me I could have had it the way I had it. So this is 6 or 8, so there's 2 options here. And then, depending on what number we choose here, there's only 3 options left here. So if this was a 6, then the options here would be 1, 3, or 8. And then I'd have 2 numbers here left that I can choose from, and then here I'll be left with 1. So I didn't have to split it up. So the number of unique numbers, lots of numbers here, that I can get here is 3 times 2 times 2, which is 12. So all in all, the number of unique even numbers greater than 65,000 with no repetition allowed is going to be 2 plus 6 plus 12, which is 20. Let's see what the memo thinks of our counting ambitions. Counting is definitely one of those areas in mathematics that I struggle with a bit. So, right, first up we have 5 factorial, 120, cool. The next answer is indeed 1 out of 20. And then the last answer is 20. And I mean, they did split this case up, so into 2 cases where you starting with 9 and ending with 6, or starting with 9 ending with 8. But that will give you 12 either way, because 3 times 2 times 1 is 6, and you have that happening twice. So so you've got 6 numbers that start with 9, end with 6, and 6 numbers that start with 9 and end with 8, and altogether you've got 12. Right, that is fantastic news. Sorry, I was trying to look at the second solution, the alternative solution, and I don't really get it. Okay, I'm not going to look at it anymore. I'm done. I'm done. End of ramble. I couldn't resist. I just had to look some more. So it's actually such a cool approach that they have. So the alternative that they suggest is, okay, you have these 5-digit numbers, and instead of so we kind of looked at the first restriction being the fact that the number has to be greater than 65,000. So we kind of nailed down that it has to start with a 6, an 8, or a 9. But the alternative that they suggest is you could start by looking at the restriction of it being an even number. So because the only numbers we're picking from are 1, 3, 6, 8, and 9, that means we're either ending with a 6 or we are ending with an 8. And then from there we kind of think about, okay, what does this, so how does this restraint interact with this case, for example? So if we need it to be a number bigger than 65,000 and it ends with a 6, okay, so it definitely can't start with a 1 or a 3, because then it would be smaller than that. So the only options we have for the first slot are 8 or 9. We have 2 options. Then for the second slot, we have 2 numbers less to pick from. So we're picking from 3 numbers for this slot. And here we're picking from 2, and here we're picking, we only have 1 number left that we can choose. So just to show you how this plays out, like if this started with an 8, for example, then for this slot we're either choosing from 1, 3 or 9. So let's say then it turns out to be a 1. Then here we're choosing from 3 or 9. So let's say then it's a 9. Then here we're just left with 3. We only have one choice. So that's what these little numbers under the slot mean, right? So that means that using taking into account this restraint and the number having to end in a 6, then there are 2 times 3 times 2 times 1 possibilities, and that is 12 of them. Okay, and then the case where the number ends with an 8, right? So I'm just going to write these numbers out again here for ease of access. Okay, so if the number ends with an 8 and we need it to be greater than 65,000, so again 1 and 3, it can't start with 1 or 3. It's either starting with a 6 or with a 9. But with the 6, there is a bit more of a condition, because if it starts with a 6, it can't be followed by a 3 or by a 1. Otherwise, it'll be smaller than 65,000. So, with the 6, there's a bit more thinking we need to do. But if it starts with a 9, then it is going to be greater than 65,000 by default. So, I'm going to split those cases up. So if it starts with a 9, then over here we have 3 numbers to pick from, and then 2, and then 1. So then that means there's 6 numbers that start with a 9 and end with an 8. And then if it ends with an 8, but it's also the 6, so then for this slot over here, it would have to be a 9. It can't be a 3, or it can't be a 1. So it would have to be a 9. And then for this slot, then that means we have 2 numbers we're picking from. It's either the 3 or the 1. And then here we'll just be left with 1 number to pick from. So that's 2 times 1, which is 2. And if you add all of these up, then you do in fact get 20. Let's leave it at that. Cool beans. Thanks for hanging around. See you another time. Okay, I won't lie. I'm drawing this ending out because I'm thinking, I wonder how different things would be if repetition was allowed. But let me leave it at that. If you're interested in a video where we do this whole question again, but in this case we look at the case of repetition being allowed, let me know. Cool. I will really leave it at that now. Ciao.